We're going to be taking a look at the January 2015 multiple choice section. I'm going to be going over the answers and offering an in-depth look at some of the more challenging questions, but hitting everything from number 1 through 24. Again, this is part 1, just the multiple choice. So number 1, we're starting off with just a modeling function question that's basically asking us what the variable means. Usually we're asked like what the 22 would mean or what the 8600 represents. In this case, what is x? So clearly here it's representing the hours worked per week. X is time in this case. Number 2 is a non-traditional question, but this has been coming up every so often. It involves just simply like unit conversion. So this one is converting, someone did a 40-yard dash in 4.5 seconds. They're changing it to miles per hour. This can get a little confusing, so I'll try to simplify it. When you do convert something, notice my slashes there. Your units have to cancel out. So they said the whole part of this problem is like, where's their mistake? And it ends up being the 5,280 feet. That's how many feet are in a mile, but it's written the wrong way. And that goes to what I was just saying with canceling. It should really be 1 mile over 5280. This way we get the feet to cancel out and we end up with an answer that's in miles per hour. If you look in the kind of bottom right-hand section there, all the units would cancel if it was written correctly, and you'd be left with some number in terms of miles, and then denominator, your hours. Okay. For number 3, we just have a simple factoring question. We're doing a is greater than 1, eyeglass factoring. As with any factoring question, you can check just through box method, so nothing too crazy there. For number 4, we have an exponential function. We're adding 2%. The trick here being, I suppose, between choice 1 and 3. Why is it choice 1? She started when she was 2, and now we're 18, so that's 16 years. For number 5, a linear function, we're looking for a key phrase, constant rate of change. The only one where that happens is choice 3. The constant rate of change, or the slope, is 2. What would be a good domain if you're looking at online devices that someone has in their house? The answer is going to be whole numbers. Integers include negatives. We can't have that. Irrational numbers, definitely out. That's like radical 3, pi, negatives as well, so we don't want to have that. And rational numbers include fractions as well as negatives. So something's wrong with 1, 3, and 4. Choice 2, whole numbers. A good way to remember whole numbers is a whole. It starts with 0. 0, 1, 2, 3. No decimals, no fractions, no negatives. So choice 2 there. For number 7, we're solving the inequality. Just be careful. Depending on which side you brought stuff, I brought my variables to the left. You're going to be flipping the sign here because you end up multiplying by negative 3/5. Anytime you multiply or divide by a negative, we flip the sign. And why negative 3/5 am I multiplying by? When you have a fractional coefficient, multiply by the reciprocal. For number 8, this one I would grab the calculator for. Definitely not one you want to do by hand. It says, how much more is it worth, year 2 versus year 3? So you could either go to the table or simply type this in your home screen. You can see I have like the approximates there, that little squiggly equal sign. And now it says how much more, so we do have to subtract them. You don't want to be careful if you look at like choice 3 or 4. Those are the actual numbers, but I wanted to know the difference. So just subtract. And it does say to the nearest dollar, so round appropriately. For number 9, which function has the same y-intercept? So the y-intercept in the graph is negative 3, and now you have to kind of treat this on a case-by-case basis. Choice 4 has a y-intercept of negative 3. If you move the plus 3 over, you can clearly see that. For number 10, box method question, multiply the 2 out. You can see I'm literally drawing the box. Be careful, 1 and 3 are doing something with like adding or something weird. Number 11, a little tricky. So it says basically a line passes through those 2 points. What's another point that it passes through? So this is one of those problems where you don't almost like know where to start. So what I did was I created the equation given these 2 points, and then I said to myself like, hey, now that I have the equation, I can just plug in or check or calc this to see which other point works for that equation. So coming up with the equation, I'm doing the slope between the 2 points. I do my plug-in to find b, and I'm doing this manually or like by hand. You could obviously use linear regression as well. So the equation ends up being 2x plus 5. Now I'm going to type it into y equals and just check my table. I see that 2, 9 is in the table, so I could conclude that the line passes through 2, 9. For number 12, we have a transformation question. What do those three things do? What does 3 do? What does minus 2 do? And what does plus 1 do? 3 is going to make the graph more narrow. Minus 2, IHOP rule. Minus 2 opposite is going to move it 2 to the right. And the plus 1 is going to move it 1 up. For number 13, Connor going to the carnival. Kind of like modeling, but not an equation and inequality. He can spend at most. At most implies less than or equal to 16. You solve this, move the 450 over, divide by 0.79. This is one of those problems where we have a decimal, but we have to think realistically. He can't go on 15 rides, even though mathematically it might round to that. He can't afford the 15th. Number 14 we've seen before in our box plot lesson, so you might have remembered just doing this problem, but with IQR, you could visually look for it, or the actual calculation is Q3 minus Q1. So you could see I even wrote, like visually, you could just tell Pelican Beach is going to beat out Whispering Palms. For number 15, what is the y-intercept? So in an exponential equation, the y-intercept is going to be like the coefficient of the base, the thing being raised to an exponent. So in this case, it's 5,000. So it's either 3 or 4. 5,000 is the amount of money initially, not after some amount of years. The y-intercept is the starting amount, so choice 4 makes no sense. For number 16, this is a literal equation, rearranging formulas, transforming formulas, whatever you want to call it. We're going to solve for r. So we get rid of pi h by dividing by pi h, and then we undo the square by taking the square root. And be careful, everything's underneath the square root there. For number 2, what is this getting at? Number 17. Number 17 is getting at completing the square idea. Yes, there's other ways you can answer this. You could sit there and box them all out, but really what they were testing is, do you know how to complete the square? So the number you would add to both sides if you were doing CTS would be 9. You end up getting x plus 3. Remember, it's always half. You have the 16 now because you added a 9, so choice 4. But yes, there are alternatives, obviously, by working through the choices. For number 18, I wrote use graphing calculator table or the intersect feature. So you have this like system and they want to know what's true about it. So you don't actually have to pull out graph paper and do this. The only thing you would have to do if you're using a calculator is that linear equation, the 3x plus 3y, is get it in y equals. And once you do that, you'll see that 6, 3 is a solution. Technically, you could also go through the choices and kind of plug in. Like you can plug in 6, 3 and see if it just makes both equations true. The definition of a solution to a system is it satisfies or it makes the equation, both or all of the equations true. Not just one of them, not one or the other, but all of the equations in the system. For number 19, I set it up like this. So I took the 16 that they told me for Miriam, and I said like, all right, what could n be to make it be the same? So I did some rewriting. I rewrote 16 as 4 squared. Now with exponent rules, my double exponent, I can make 4t. You multiply there. And now you can see they clearly match up, which means n must be 4. You could do kind of like a guess and check approach with the choices, plugging them in and seeing if it creates the same exponential model. But this is the quote-unquote real way of doing this one using exponent rules. 20 was the most commonly asked question in the, like, hey, what was the hardest question on this? So, not asked, I guess, the most referenced question in that question on the Google form. And it really wasn't that bad, but I guess some people just didn't know what it was asking. This is really getting into recursive stuff. More commonly, we see this with like a sub 1, but here they're using function stuff. So they say f of 0. If we look at the second line here, that is a recursive rule, right? Hey, to go from one term to the next, you multiply by -2 and you add 3. That's the relationship between n plus 1 and n. It's just saying previous or next, depending how you look at it. For n is greater than 0, that just means like we can only use this. They're calling the first term the 0th term, which is also a little confusing, but they're saying, hey, you can only use this for 0, 1, 2, 3. And we want to find f of 2. So we start by finding f of 1. We plug in the previous term, which was 2. We do our math, our rule, multiply by -2, add 3. We get -1. Now we take that answer and plug it in. That's how recursive stuff works. You keep kind of like taking the answers that you get and plugging them in to find the next one. And we end up getting 5 there. Number 21 is an AROC question. You actually have to find your y values here by plugging in, use a calculator. So we plug in a 5, we plug in a 10. We now kind of treat these as coordinates, 520, 1080. And remember, AROC is the same as slope. So the change in y is 60, the change in x is 5 seconds. So we have 12 meters per second. For number 22, double dots. You do dots once. Be careful if you circle choice 1 there. P squared minus 9 is dots capable a second time. Also be careful with choice 4. Sometimes we overdo dots. Remember, you can't do it to the p squared plus 9 because it fails the first letter. It's not a difference, it's a sum. It looks like it, but it's not. Number 23 is what we called way back when we did this lesson an adjustment function. What do I mean by that? Look at the difference between choice 2 and choice 4. Those are the ones that you should have boiled down to even if you were unsure of it. Choice 1 and 3 don't really make sense. So for 2 and 4, what's the difference? Choice 4 has the correct adjustment. This is that idea of overpaying or double paying, whatever you want to call it. We need the z minus 1 there because we already paid for an ounce. When we paid the 46 cents, we paid for the ounce. So I call this the extra charge, the extra fee. We don't want to get double charged there. So let's say I end up mailing something that's 3 ounces. The 46 cents covers one of those. I'm only really getting charged for 2 ounces at the extra. So in other words, you take away 1 from whatever the weight is. That has that adjustment. Sometimes be extra careful. You might not see the bubble like this because they might have just distributed in combined like terms. So that can be a little tricky as well. You might see some random numbers, assume that it's wrong, but it's just that they distributed, in this case, the 0.2 to the z and the minus 1, and then combined like terms. So be on the lookout for that. And last one, number 24, another kind of common question here. Remember, these are just taking factors to the roots. In other words, you solve them. So we're looking for roots of 0, 2, and -5. And the only one that meets that criteria is choice 1. Choice 2 only has 2 roots. It's got 2 of them correct, but it's missing the x equals 0 root. That's also a quadratic or a parabola, so that's out of the mix. Parabolas can't have 3 roots. And for choice 3, what's wrong with choice 3? We got a -2 instead of a +2. It's kind of messing up the signs there for maybe someone that just thought it was 0, -2, and 5. So choice 1 only. Okay, this was a quick little recap, hopefully it wasn't too long, of the multiple choice for the January 2015. I'll post these solutions for you to look over carefully, but hopefully this video cleared up any additional confusion you may have. Thanks for watching, and as always,